Hello everyone, welcome back. In the previous sessions we studied about the unit number 6 content. Unit number 6 having components, component diagrams, deployment and deployment diagram. With the help of these two diagrams, if we know about these two diagrams, we complete our syllabus. Okay. In this class, we have to know component diagrams. What are those diagrams? Component diagram. We studied what is a component and how we use the component particularly in the software systems. That component diagram contains what kind of information is containing in the component diagram is we have to see now. Component diagram. Component diagrams provide a physical view of the current model. What is that? Component diagram, deployment diagram, class diagram. All diagrams are object diagram representing the architectural view, that is the physical view of a computer system. Here, the component diagram also provide the physical view of a particular system and which shows the organizations and dependencies among software components. What it shows? It shows the organizations which shows the organizations and dependencies among software components, including source code components, binary code components, and also the executable components also, which shows the executable components also. Right? Also, we show the externally visible behavior of the components by displaying the interfaces of the components. Visible behavior is also externally behaves and which produce the visible behavior. The component diagram calling dependency among components are shown as dependency relationship here and between the components and the interfaces of the other components. Components and interfaces of the other components. The interfaces actually belong to the logical view, but they can occur both in class diagrams and as the component diagrams. What is the interface? Interface. What is an interface? Interface actually belongs to the logical view. Interfaces belongs to the logical view, but they can occur both the class diagram and also component diagram. Interfaces. Interface symbol that we see for the slides. Interface symbol is also shown in this. Contents of component diagram. What are content? What contents are available in the component diagram? Contents of component diagram. A component package. Package is there. Components, interfaces, relationships. With the help of these, the combination of these four, we have to draw the component diagram with the help of these four. Component packages, components, interfaces and the relationships. Interfaces and the relationships. Okay, those are we have to see in the component packages. Those we have to see in the component packages. Next, component package. What is a component package? Package, how do we represent? Component packages represent clusters of logically related components or major pieces of your system. Major pieces of your system you have to place in this shape, this symbol. This is called, what is this? Package. Package. What is this called? Package. Package symbol is this. Business rules is the package which have some business rules. That information, the rules of the business, we have to keep here. Okay. So next, we have to see B. Next one is the components. First one is component packages are representing with the package symbol. And the second one is the component represents. What components represent? Components represents a software module. Already we saw in the previous class. The component module, the source code, what the information, the representation of a component, the source code, binary code, executable code, DDL, dynamic linkages also represent for the components, with as well as defined interfaces. The interface of a component is represented by one of several interfaces elements also you represent in the component diagram, right? The component provides this symbol. Component is also provides with this symbol, rectangle with having some shapes. What we use this shape is this component. Component is that component representation, and the name of the components also you write here. The name of the component. The name of the component also you write. How do we write the name of the component? Also you have to write the name of the component here. Right? First one is the package. Second one is the component. This way we represent. And the third one is interfaces. Very, very important. Interfaces, representation and also interface. An interface specifies the actionally visible operations of a class or the component. External visible operation of the class has to be represented with the help of interfaces. With the help of interfaces, those interfaces are representing visible operations of a class and the visible operations of a component, and has no implementation of its own. No implementation is there, but an interface typically specifies only a limited part of the behavior of a class or a component. Limited behavior, limited part of the behavior of a particular interface will be representing like this. The interface is represented as a circle with connector, that is a interface representation. Interface. What is an interface? Visible or externally visual operations will be represented in the interface. Interface symbol is that, and the interface typically specifies only the limited part of the behavior of a class or a component. Limited part of a behavior of a class or a component we represent with the interface, right? And common uses, 4 kinds we studied. So interface, package and the component. And next, common uses. Common uses. To model the source code is one use. To model executable releases. To model physical databases. To model adaptable systems. With the help of these adaptable systems and to model these kind of common uses, we have to provide to draw the component diagram. Right, let me see common modeling technique use. What kind of common modeling techniques use to draw the component diagram? Let me see some modelings which are available. We studied already. To model source code, to model the source code, to model the executable releases, to model the physical database, and to model the adaptable systems. With these kind of 4 modeling techniques, we have to draw component diagrams. So first of all, we have to saw the source code. What is the source code? Modeling source code. How do we model the source code of a particular component diagram? Either by forward or reverse engineering, identify the set of source code files. First of all, we identify the set of source code files of interest and model them as a components or a stereotyped as a file. Model them as stereotyped. Already we saw 4 to 5 stereotypes are available. Other than the stereotypes, you have to also, you may create your own stereotype with the help of these brackets. In between these brackets, you have to write something about like a stereotype. That also uses in forward engineering and the reverse engineering also. For larger systems, use packages. For the larger systems, you use packages also. Combine all the files which are available for your system. You combine all the files and keep those files into a package, right? To show groups of source code files, yes. Well, how do we combine all the files in a particular package that will show us a group of files for a particular modeling of a source code? Next, consider exposing a tagged value indicating such information as the version number. You may also indicate the version number in between the square brackets. In between the square brackets also you represent the version numbers also. For this of the source code file, its author name and the date in which the last change also you may mention with the source code while you are designing the particular component diagram. And there also you have to provide that information in between these brackets. What are these brackets you may represent, right? And also model the compilation dependencies. Modeling the compilation dependencies. These files using dependencies, and again you use some tools to help generate the relation between the compilation dependency in the source files also. You may consider and you may use some tools also, right? So next, to model the executable release. To model, how do we model executable release? In the previous we studied to model the source code. Now we modeling the executable release. Identify the set of components you would like to model. What kind of components you would like to model? You have to identify and write those models in one sequence way. And right, typically this will involve some or all the components that live on one node. Is that all components are living in one node or not? You have to find and you have to represent those all live executable releases in one node, or other distribution of these sets of components across all the nodes will be of your particular system also. You have to provide that executable releases, you combine and you have to get together and keep all that information into one place. Consider the stereotype of each component, where you provided and you identified some components. What kind of components you have, the components also you found some stereotype. Identify the stereotypes. Stereotypes. We represent stereotype, the meaning. Those stereotypes will be having in between these lines, right? So these stereotypes you identify set of stereotypes. For most systems you will find a small number of different kind of components, such as executable things are libraries or tables, files, documents. For those you represent stereotypes also. For every system you may have all these. Some system may contain many tables, some system may contain documentations, or some system source code, executable code. That code or that information you found, and you also use some stereotypes representation. And for each component in this set, consider its relationship. Identification, and after identification, provide some stereotypes. after providing some stereotypes, you may have to connect all these components. At the time we go, we see the component diagram. You collect all this information and draw the particular information. At the time you may have a complete component diagram with the help of these three. First of all, create or identify the components. After identifying, you have to use the stereotype. After identifying stereotypes, components, you use the relationship between them. These 3 points are those, right? Next, modeling a physical database. Software we modeled, and after that releases we modeled. After that we have to physical database should be of model. Identify the classes in your model that represent your logical database schema. Databases, physical database, the data which we have to store in our particular system, that is a database. For that database, you identify the logical database schema, select a strategy for mapping these classes to tables. Actually, how do we represent the data here in this? That data is of some tables. Data is available of some table. You identify, you keep that data. Consider that the physical distribution of your database, your mapping strategy will be affected by the location in which you want to data is live on your deployed system. Deployed system means that the last system at the end of the system where the particular data is available. For that you have to create some databases. That database is of particular schema. That schema is available with the help of the tables, right? Here, to visualize and specify, construct and document your mapping, create a component diagram. To visualizing the data, particular specifying the data or constructing data documentation purpose, you should use to construct a component diagram which contains some components, stereotypes and tables. What component diagram contains? Component diagram contains components, stereotyped, and also this combination will be saved in the tables also. Whereas possible, use tools to help you transform your logical design into a physical design. Maybe some languages provide some tools, that is rationalist provides some additional tools. You may use those tools to provide some logical design to the physical design also, right? And the last one, modeling adaptable systems. What is adaptable? Supporting systems. Adaptable means consider physical distribution of your components that may migrate from node to node. Physical system, node to node. One node is there, another node is there. You have to distribute the information to the different components. You can specify the location of a component instances by making it with a location tagged value. Location tagged value. Where do we give location tagged value? With the help of some scope resolution operator. Okay. With this scope resolution operation, you have to provide some tagged values, adapted systems. For that systems, you provide some location also. For example, you may use under J to UK, you may have Pignal Lara is under J to UK. Okay, J to UK is under state government. Okay, for that location you may have to use with the help of some stereotypes. Okay, that location is also provided for adaptable systems. Okay. If you want to model the actions that causes a component to migration from one system to another system, if you want to model, so you have to model after seeing this migrating, create a corresponding interaction diagram that contains component instances, and also you can illustrate a change of location by drawing a same instance more than once, but with the different values for its location tagged values also. So what ultimate goal is to provide some location that location with the help of that location where it's available with the corresponding information, that takes that information and you provide the information, complete information with the square brackets also. Let it changes location where the tagged values also you may give. Okay. So with the help of we completed to draw, component diagram. Component diagram is a diagram which provides a physical view of a computer system or the physical view of a model. Component diagram have packages, components and also which has some interfaces. Okay, with this we completed component diagram. We will meet another topic with new topic. Thank you.